Select the major product of the following reaction. So if we look at what we are given in this reaction, we have a carbonate, specifically diethyl carbonate, as one of our starting materials. We have sodium ethoxide, so we really have ethoxide here as the base, the sodium ion being a counter ion, and we have a ketone. And so what this is this is an example of a crossed condensation reaction. And like with all of our condensation reactions, we're going to be forming an enolate out of one of our carbonyl compounds, and then that enolate will attack the carbonyl carbon of the other. And so in the case of this reaction, the diethyl carbonate has no alpha hydrogens, and that's because we have an oxygen on either side. So what this means is that our diethyl carbonate is going to be the electrophile in this reaction. And so that means that our ketone is going to be the nucleophile. And if we take a look at this ketone, we only have alpha hydrogens on one side. So what we're going to have take place first is we're going to remove that alpha hydrogen to give us an enolate. So this can react with the base. So we will just draw this as OET, ET being the abbreviation for ethyl. And we can remove that hydrogen to form the enolate. So there we are forming the enolate. So I'm going to go ahead and draw the structure of the enolate over here. And this enolate is, of course, resonance stabilized with the carbonyl. We can push these electrons in and then up onto that oxygen. But I've chosen to draw it in a way so we can see that it's this alpha carbon that is your nucleophile. And so what that nucleophile is going to do is it's going to attack your electrophilic carbon of the carbonate. And so we can see this attack. And it's going to push these electrons up onto the oxygen. So I'm going to go ahead and draw the product of this. It'll be a tetrahedral intermediate. So we have our carbons that came from our enolate. And then we have a new bond that we are forming. So there's the new bond. And that new bond is between this carbon, or this one, and that carbonyl carbon. And so I'm going to highlight the carbons of the carbonate here in pink. So the new bond is here. So we're going to color code make everything from this carbonate in pink so that we can see where it's at. So we have our new bond, we have that single bond oxygen, and then we still have both of these ethoxy groups. So you have this tetrahedral addition intermediate, and just like in all of the other reactions we saw where we attacked a carbonyl, if you have a leaving group, these electrons can come back down and kick off the leaving group. And we actually have two leaving groups here, so this is definitely going to happen. So our electrons can come back down and we can push off one of those ethoxy groups. And so what that will form is we're still going to have the ketone. We'll have that CH2, the new bond that we formed in this reaction. So that new bond, and now we have, again, the carbonyl and OET, and we've also formed some ethoxide, okay? And this is going to be the overall product of this reaction, so hope we can recognize this down here as option C. But to explain why we need this acid workup, this ethoxide that we form here is a base. And so being a base, it'll react with any acidic hydrogen atoms. And these hydrogens that are in between the two carbonyls have a pKa of approximately 10. And if you're looking at the conjugate base of your ethoxide, you're looking at ethanol with a pKa somewhere closer to 16. So what that means is this base is going to remove that proton, whether you want it to or not. So that is what's going to happen in the next step, is that this ethoxide can remove one of those two protons. So you can draw it out, and we can show the ethoxide removing that proton. And this is a favorable step forward and actually tends to drive this reaction towards the products, much like we saw in the Claisen condensation. And so we have the C with a negative charge there. I'll still put our new bond here in green. And then the ethyl ester that came from the carbonate. And so this is going to be the product after step 1. And then when you treat it with HCl, probably aqueous HCl, then you can go ahead and put that proton back on. Okay, so we'll draw in some H3O plus, which if this is aqueous, and all HCl, unless it's HCl gas, is aqueous, we can grab the proton from here to get to that product.